Introducing Warp-402, cross-chain payment system powered by Avalanche X402. The problem: developers face high technical barriers and missing primitives on Avalanche, forcing them to rebuild payment logic from scratch. This complexity creates friction, leading to wasted development time, buggy implementations, and abandoned cross-chain features. The solution: Warp-402. It is a production-ready protocol that wraps the existing X402 standard, making cross-chain payments as simple as an HTTP request. It abstracts away protocol complexity to provide a seamless developer integration. Why WARP 402? The protocol accelerates development with a TypeScript SDK, pre-audited smart contracts, and single command deployment. It also includes a unique JSON RPC interface, making the system natively compatible with AI agents. So here is how it works. The user funds the transaction on the sender chain, which is securely bridged by validators via teleporter. Finally, the destination contract validates the receipt and unlocks the resource to consume the payment. Let's say how to initialize our WARP SDK. So initially we have to set up the sender chain and the receiver chain by giving the RPC URL chain ID, blockchain ID, the source and destination address that we are planning to teleport the assets. And after that, we have to set up the payment ID in which it will be used to verify the payment at the receiver chain. For that, we have to set up the networks locally as well as the relayer in order to transfer the payment from the sender chain to the receiver chain. For that, we have started up two networks locally. Followed by that, we have to deploy our contracts for the sender chain as well as the receiver chain, which can be done using two approaches, which is the CLI by running the CLI commands, and the second approach is by making use of our code snippets that we have given in the SDK in order to deploy our contracts. So let's go and deploy our contracts using the SDK. The reason why we are deploying our own contracts is that we can set custom blockchain for the sender as well as the receiver chains. Once the contracts are deployed, we will get the contract address for both sender chain as well as the receiver chain. These contract addresses are used to send, verify, and consume the payments on the respective chain. Let's see a quick demo on how to send the payments from one chain to another. So let's update the deployed contract address for the both sender chain and the receiver chain. Once the payment is initialized, it will check the wallet balance of the sender address. If there is sufficient balance, they will set the amount. After the payment is complete, it will generate a payment ID, which is used for the verification at the receiver chain. So let's start the payment script to run the sending process. We can see that the payment has been initialized and it will generate a payment ID. This payment ID is used to verify the payment on the receiver chain. So let's verify the payment that we sent from the receiver chain using the payment ID. So let's go for the verification script and replace the payment ID with our generated payment ID. Let's run the verify script to start the verification process on the receiver chain. We can see that the payment is verified on the receiver chain. Once the payment is verified, it will be consumed on the receiver address and the payment will be sanctioned onto the wallet address. WARP 402 enables users to pay on chain A and instantly unlock services, subscription, digital assets, compute requests on chain B through trustless and automated verification. That's it for WARP 402. Pay anywhere without barriers.